Recording is start. Now you can note down this problem statement. Do it fast. I think noted everybody. Okay. So I'll go to the next
Wait,
problem.
sir. Wait, sir.
Okay.
Done, sir.
Okay. So we will go to next problem. I think for this we have to provide figure. I will give you the figure later. Okay. This one, two horizontal plates are placed 1.25 centimeter apart. There are two plates. They are placed horizontally. The distance between them is 1.25 centimeters. The space between them being filled with oil of viscosity 14 poise 14. Okay. Calculate the shear stress in oil if upper plate is moved with a velocity of 2.5 meter per second. Okay. So here you can imagine that there are two plates. This is upper plate. This is the bottom plate. Bottom plate is not moving. Only the upper plate is moving. Okay. So the relative velocity will be the same as whatever the velocity with which the upper plate is moving. Okay. So upper plate velocity is given. This is 2.5 meter per second. And it is clearly mentioned here. It is a horizontal plate. There are two horizontal plates are placed apart 1.25 centimeter. So this is the distance between the two plates, 1.25 centimeter. Okay, and the space is filled with oil whose viscosity is 14 poise. Whose viscosity is 14 poise. Then we have to find out shear stress. Shear stress. Okay, shear stress in the oil when the upper plate is moving. So in this case, we have to find out tau value. So easily can find out du. Du will be 2.5 minus 0 because this is fixed. So dy is given in 1.25 centimeter. This has to be converted in meter. Okay. So divide it by 100, you'll get the answer. So du is this, dy is this, and what else we need? We need viscosity. It is given in poise. Divide it by 10, we'll get it in SI unit. So this is the equation. Tau is equals to mu into du by dy. Okay. Then substitute the values. So it is 14 by 10. Here only it is substituted. 14 by 10. Then inside the bracket, 2.5 meter per second is the velocity. Du. Then dy is 1.25 into 10 power minus 2, which is here. So if you calculate, you will get the value to be 280 Newton per meter square. 280 Newton per meter square. Okay. So just if you can confirm, I think you are getting the same answer. Just calculate and confirm. Can somebody confirm?
Yes, sir.
Okay. So we'll go to next problem. See, this is the problem statement. The space between two square flat parallel plates. There are two parallel square plates. The space between the two parallel plates is filled with oil. Each each side of the plate is 60 centimeter. Okay, the thickness of the oil film is 12.5 centimeter. The upper plate, which moves at 2.5 meter per second, okay, required a force of 98.1 Newton to maintain the speed. To maintain the speed. So here it is given that there are two plates. There are two plates. So you can consider that one plate is fixed and the upper plate is moving. So the space between them is 12.5 mm, 12.5 mm, and the space between them is filled with the oil. Is filled with the oil whose viscosity is not given. We'll find out. We have to find out the dynamic viscosity of the oil in poise. We have to find it in poise. After that, we have to find out kinematic viscosity of the oil in Stokes. If the specific gravity of the oil is 0.95, we have given specific gravity. Okay, so this is a problem statement. So you can see what all things are given. It is given that the space between the two plates is 12.5 mm. This has to be converted in meters. Then upper plate is moving with 2.5 meter per second. This is moving with this much of velocity because we are applying so much of force. We are applying so much of force. Okay, this is the velocity. This is, you can say, this is moving and this is stationary. So if you write du is equals to u, this is u and this is 0. 0. Bottom plate velocity is 0. Okay, so u or du is 2.5 meter per second and the force applied is 98.1 Newton for this much of velocity of the plate. Then mu we are finding out. Also we are finding out kinematic viscosity. We have to note that specific gravity is 0.95. So these are the parameters. These are the parameters. So again, we can use the equation tau is equals to mu into du by dy. We should know that tau is not given directly. Tau is given indirectly. Tau is given indirectly. Okay. So this is the formula what we can use. Tau is equals to F by A. So we know that the force applied. How about the area? Area, it is mentioned. It is mentioned they are square plates. Square, flat parallel plates. So each side of the plate is 60 centimeter. Okay, this is the plate, no? The plate surface which is exposed to oil, which is exposed to the oil, that surface, it is shown here 60 centimeter by 60 centimeter. Okay, so what will be the area of this square plate? It will be 60 into 60, but it has to be converted in SI unit. So this surface will be exposed to the oil, the bottom surface as well as the top surface. I am talking about inside two surfaces, inside bottom surface and inside top surface. Okay, so this is how we can find out the shear stress after substituting this. So if you substitute, convert it in SI unit, we'll get to know that the shear stress value is 0.02725 into 10 power plus 4. It is in the denominator, no? It comes to the numerator. Newton per meter square. Newton per meter square. Okay, so that is the value of tau. So in here we have to substitute. Here we have to substitute. Then we can find out the value for mu. We can find out the value for mu. The standard equation is tau is equals to mu into du by dy. So this is modified according to the requirement. So mu is equals to tau divided by du by dy. And after substituting the values of tau, du and dy, we'll get the answer in SI unit, that is Newton second per meter square. This has to be converted in poise. To convert in poise, just multiply this answer by 10. Just multiply this answer by 10, which is already done here. Now we have to find out kinematic viscosity. This is dynamic viscosity. So what is the relation between kinematic viscosity and dynamic viscosity? Can anybody just tell the definition if you remember? What is the relation between the dynamic viscosity and kinematic viscosity? Yes, please.
The ratio of viscosity to density.
Okay, the ratio of viscosity to density. So here we know the value of viscosity. Do we know the value of density? Do we know the value of density? That is the question. If we know, then you can take the ratio. No, now density is not given directly. How to find out density?
By specific gravity.
By specific gravity, correct. So specific gravity is given as 0.95. Okay. How to find out density? So we have to use the definition of specific gravity. What is the definition of specific gravity? Somebody telling, no, you are telling it correctly, just continue. Whatever you are telling, you just continue. What is the specific gravity definition?
Density of fluid to the density of liquid water.
Okay, so the density of fluid which is given, okay, in the
To the
problem, the
density of standard fluid.
standard fluid which is water. So
Water.
water density we already know,
Yes, sir.
which is 1000.
1000.
Correct. So now by just cross multiplication, we will get the density of the given oil to be 950. 950. Correct. So this is 0.95. 0.95 V is equals to density of the oil divided by density of the standard oil, which is water. So we will get the density of the given oil to be 950. Okay. So I think here it is already done. The specific gravity is equal to density of the fluid, which is given, divided by density of the standard fluid. So 0.95 is equals to density of the fluid divided by 1000, which is water. For water, standard fluid is water. So density of the given fluid is 950 kg per meters cube. So as you told, the definition is tau is mu. This kinematic viscosity is equals to mu by rho. Mu already we have found in poise. Okay, we have found in poise. This is the value. But here we will substitute in SI unit only. We'll substitute in SI unit. Further, we will kind of convert the value in Stokes. It is better to find out in SI units. So this is 1.365 into 10. This is in poise. So, but we are using this value 1.3625 SI unit divided by 950. 950 kg per meter cube. Okay, this is also SI unit. So whatever answer we get, that we will get in again SI unit only. That is 1.4342 into 10 power minus 3 meter square per second. This is kinematic viscosity. Now we know that Stokes to convert in Stokes, it has to be converted in centimeter square per second, which is Stokes. You can see here, centimeter square per second is Stokes. So meter square to centimeter square, if you convert now, 1 meter is equal to 1000 centimeter. So 1 meter square is equal to, sorry, it is not 1000. 1 meter is equal to 100 centimeter. So 1 square meter square is equals to 100 square centimeter square. So that 100 square will give you 10,000 or 10 power 4. So you'll get the answer to be so much. Okay. So this is simple conversion, but just don't multiply 100 as square term is there. You consider square also. So that is why instead of getting 100, you are getting 10,000 here because there is square. So this centimeter square, if you write it in, we can directly write it in Stokes. So as per the problem statement, we found viscosity in poise and kinematic viscosity in Stokes. Okay. This is one more problem. Okay, you please note it down. Please note it down. Note down and write down the given things also. Try to solve it. You take just 5 minutes. take 5 minutes to try and solve the problem.
Sir, tau is 0.25 or 452, sir.
2452, 2452, 2452. Okay, I think you noted down. So here you have to find out the kinematic viscosity. Okay, find the kinematic viscosity of an oil having density. Density is clearly given, 981 kg per meter cube. Okay, the shear stress at a point in oil is 0.2452 Newton per meter square. Tau is also given, and velocity gradient. And velocity gradient at that point is 0.2 per second. So try to understand this one. Velocity gradient is given. Velocity gradient is given. So I'll just try to tell you what is velocity gradient so that you'll get a fair idea. So velocity is only du. Velocity gradient is du by dy. I think it's been already explained. Just I want to tell you. Okay, du by dy. What is the unit of du, which is velocity? Unit of du is velocity. So that is meter. Okay, meter per second, right? Unit of velocity is meter per second. So we can write it like this. Into, this is the velocity of it is the unit of velocity, meter per second, into what is the unit of dy? Dy is distance, which is in the denominator, that is meters. Okay, so I can write it here 1 by meter. So if you check clearly, the unit of du by dy together, it gets cancelled. Meter will get cancelled. We will be left out with just 1 by second or per second. Per second. So unit, this term is known as velocity gradient. This term is known as velocity gradient. So here we are considering velocity with distance. With distance. Okay. So if I refer to the sheet or the problem statement, and velocity gradient at that point is 0.2 per second. I hope you got it. So they have given the value of du by dy. Du by dy. I hope that is clear. So the values are given. This kinematic viscosity we have to find out. Density is given. Tau value is given. Du by dy is given. Okay, so we can see here. Du by dy is meter per second upon meter. Meter and meter will get cancelled. We'll be left out with per second or 1 by second. So as per the problem statement or the definition, tau is equals to mu into du by dy. So mu value we have to find first, then we can find out kinematic viscosity. So mu is equals to, this entire term goes in the denominator. So tau divided by du by dy. Tau value is 0.2452. You can see here, this is here in the denominator if it goes to the LHS side. So that entire term du by dy is 0.2, which is given here. So we'll get the value of mu is equals to 1.226 Newton second per meter square. Okay, and rho value is also given in SI unit. So just you take the ratio. Mu, this kinematic viscosity is equal to mu by rho. So if you substitute, you'll get the answer, which is 1.249 10 power minus 3 meter square per second. Okay, if you convert it in Stokes, just multiply by from meter square to centimeter square. We know that we have to multiply by 10 power 4. So after multiplying, we'll come to know that kinematic viscosity value is 12.49 Stokes. 12.49 Stokes. Okay. So these are the problems, simple problems, but with some minute changes. Now, I hope you understood that velocity gradient. What is velocity gradient? Okay. Usually gradient means you will be measuring the parameter. Here it is velocity. We are measuring velocity with respect to distance. That is gradient. There is something called temperature gradient. So in that case, we will measure temperature with respect to distance. Maybe dt by dx, dt by dy. Right? dt is temperature difference. That is temperature gradient. So earlier you have written no temperature difference, but temperature gradient means it is with respect to distance. Here velocity difference means just du. Velocity difference is, or relative velocity is just du. If you want to consider the entire term is velocity gradient. Okay, I think this has already been explained. Just I'm repeating it. Okay. Just check is the answers are matching. I hope the answers are matching.
Yes, sir.
Okay. So I'll just
Yes, the answer is 12.49.
okay, perfect. So just note down this problem. Note down the problem. I'll read it for you. Determine the specific gravity of a fluid having viscosity 0.05 poise. It is in poise, okay, and kinematic viscosity 0.035 Stokes. So only it is given that viscosity and means this viscosity or dynamic viscosity is given, kinematic viscosity is given. You have to find out specific gravity. You have to find out specific gravity. Very simple. You can do it in 2 steps. Yes. Can anybody tell the answer? Can anybody tell the answer? Yes, somebody please tell the answer. I'm waiting for your answers. Yes, how much? Can you just repeat?
Zero point 142.
Okay, let's just check the answer. It's 1.428. You're telling almost near. Just check where is the mistake that you have done. Here is the simplification. Mu value in is 0.005 because you have to divide it by 10. So that is Newton second per meter square. Kinematic viscosity is given in Stokes, no? So just multiply it by 10 power minus 4. That will give you in meter square per second. Now both are in SI units. So density value, you know, density is the basic definition is this: kinematic viscosity is equal to dynamic viscosity upon density. Just modify it, you'll get the value of rho. That is, this one is the equation. So if you check, you'll get this answer: 1428.57. Okay, this is the density of the given oil. But specific gravity is density of the given oil divided by density of the standard oil, which is water. So to find out this specific gravity, we have to divide it by 1000. So just in one decimal place, you are getting something wrong. Just check where did you do the mistake. I think here I have just conversion mistake. Either in here you have done some mistake in conversion. Otherwise, the answer is 1.428.
Sir,
Okay,
it
I
is
hope
correct.
it is correct. It is correct. So
So
if there is a
1.427.
4 to 7 or 4 to 8 in that range only, no problem. This is the correct answer. Those who have got it correct, no? That is correct. Okay, Arun, did you